There we go. Let's get the volume up. All right. Okay, so questions about that first step that you guys want to ask about. This is the mid-segment theorem, meaning that if you have a mid-segment of a triangle, that means that there's a segment in the middle. It crosses the midpoints, right? And it's always going to be in such a way where this mid-segment is half of the other side over here. That's because these are also cut in half. So there's a sense of proportion that's happening here. Questions? Okay, let me do 3941 just to make sure you guys understand what's happening here. And those are very good test style questions. Yeah, it looks like they're fixing the projector. I see the guy at the ladder. All right. So anyway, when you see this right here, PQ is what fraction of RT? Remember, it's called mid-segment, so PQ is what fraction of this guy? Go ahead, Nina. Half. There you go. Half. Thank you, Nina. Half of RT. And PQ, you know, is x plus 9. You get half parentheses 4x minus 27. Now, what I would do, you could distribute the 1/2 if you like, or multiply both sides by 2. Up to you. If you multiply both sides by 2, you eliminate fractions instantaneously because those just go away. So you get 2x plus 18 equals 4x minus 27. I know you guys can combine like terms just fine, just be careful. 2x equals 45. X is 22.5. But remember, the question is asking for length of RT, not what x equals. So then probably best to use a calculator, but if you do 4 times 22.5 minus 27, 90 minus 27, should get 63. So it should be D. So hopefully that process, and I'm recording this, so you guys have the access to this recording. And that's a great way to study too. I'm going to talk about tomorrow how to study for an assessment. And so like one way is not watching all the videos because that's going to be ridiculously long, but you can always fast forward, right? You can always kind of like say, well, let me go to the part when Mr. E talked about this stuff and let me review that. Okay. And 41. It's more of the same thing. So triangle XYZ. Oh, that's interesting. So XY is a mid-segment, XZ is a mid-segment, and YZ is a mid-segment. So you got 3 mid-segments going on there. Okay. So therefore that's 14, right? And therefore each of these are 8. Because this is going to be half of all of this, right? XY is half of LK. And they give you the angle there. Okay, great. But which of one cannot be determined? We can totally know what KL is. I know it's 16. JY knows 14. Okay, this is where it gets kind of interesting. Angle XZL or angle KZY. I'm going to go with D. D cannot be determined. XZL is going to be 67 degrees. That's because this is going to be 14 also. So you wind up having congruent triangles as a result. Another thing that you have to realize too, which I haven't talked about yet with you guys, but we are going to go over today. I mean, I kind of vaguely talked about it the other day. Something called similar triangles. Similar triangles are triangles in the same proportion. So for example, if this were 60 and this were 50 and this were 70, okay, I totally did not do the scale, just go with it. Then this is also 60 degrees. That's also 50 degrees. And that's also 70 degrees. If they're similar triangles. The sides are not necessarily the same though, but they're proportional. So if this side were like say 2, 3, 4, again, I'm not doing this accurately. And then if this were 6, I expect it to be 9 and 12. Okay. So if I triple one of the sides to the corresponding sides, you better triple all the other sides. Okay. And we're seeing the same phenomenon happening with mid-segment because we're noticing that, yeah, that's 8 and that's 16. and that's 28, and that's 14, then we are having sides that are proportional. So, or let me just draw another situation like this here. Say this are like 4 and 4, this is like 5 and 5, and say this is like, I don't know, 4.5, then this would be 9. So that follows that 1 to 2 ratio. Okay, I think I beat this to death, so let's move on. Next up is the second set, which was 5, 7, 9, 11, 19, 21, 22, 25, 35, 71. So this is the next topic. And this is about, I think, triangle inequality, if I'm not mistaken. Yeah. The key idea here, the longest side has to be smaller than some of the other two sides, guaranteed. The longest side has to be smaller than some of the other two sides. So, like if you look at like 21, that's not okay. Because 32 is not less than 14 plus 18. But you look at 23, I'm going to have to do the math in my head. That's 104.4. 103 is definitely less than 104.4, so that's okay. So that's a yes. Because 103 is less than 41.9 plus 62.5, right? So that's what's happening there. That's kind of the big concept. Let's jump to a multiple choice problem. That's kind of more like a test style problem. Okay. So how many degrees is reserved for angle H? You have angle G's and angles G and J, which add up to what? What's 73 plus 44? Go ahead, Nan. 117, good. So how much got left over for angle H? Yes, 63 degrees, thank you. So here's what's gonna, oh, that looks ugly. There we go. So here's what's gonna happen. GH is a small side, because opposite the smallest angle. GJ is the middle side, because opposite the middle angle. And finally, HJ is the biggest side, because opposite the biggest angle. So is GH less than GJ? You bet. That is true, not false. The measure of angle H is definitely bigger than angle J, absolutely. Is it scaling? Absolutely, because all the angles are different, all the sides will be different. Then GH plus HJ, well, that's not going to be true, because remember, one side cannot be more than some of the other two sides, plus GJ is the middle side anyway. But you can't have that. Remember, it always has to be this kind of situation here. That GH plus HJ is going to be, so the sum of any two sides always bigger than the other side. So that's why that one's false. And then you just give a reason like, hey, you can't have one side more than some of the other two sides. That's impossible. So that's a big idea there. And then lastly, the last step. This mentioned in chapter 6, and we're going to do more chapter 6 today. We had 7, 9, 11, 21, 23, 35, 37, 45. Oh, is right here. What page is that? 458. So yeah, this is just more algebra, like working with proportions. I'm not going to give any that we're going to require factoring or quadratic equations. Maybe we'll do some of that stuff in our second semester, starting on this Friday, July 8th. We start doing the second half. So by this Thursday, you're done. You're halfway done with this class. Pretty exciting, right? In fact, actually, with tomorrow's 6th, we're done 3 weeks from tomorrow. It's going to be here like that, really fast. So anyway, these problems here just cross multiply. Like that's what you do. Like for this one right here, right? You just think, okay, well, 7 times 27, whatever that is, equals 21y. And then use a calculator and work it out. Like, that's not that hard. I think you get 81. No, what do you get? 9? Yeah, I think you get 9 if you work it out. You get 9 for that one. Let's look at some of the multiple choice problems. So that's kind of the big idea, is just a lot of cross multiplying, you know. Let's look at maybe some of the multiple choice problems near the end. Yeah, let's look at 45. That's a good one. Which following is equivalent to this? What I would do is I'd cross multiply and check it out. Okay, 3y equals 5x. Okay. What you need to do is you need to see the same exact thing in one of the choices. G instantly I know doesn't work. That's the other way around. So I'm going to cross that one off. And likewise with f. 3x equals 5y, no way. I do like h. I do get 5x equals 3y. I think we have a winner here. And j, no way. So it's got to be h. Cool. All right. Okay, so those are the big ideas there. We're okay? Ready to move on? Okay, let's move on. Let's go to, and looking at our schedule, always good to kind of just check, make sure we're staying on target. Or is it scheduled first half? And I'll have the second half schedule ready for you guys by Friday. Yeah, so we're doing 6-3, 6-4, 6-5. And whatever textbook problems I'm going to assign, we'll try to work on that today, and maybe minimize your homework, or maybe not have homework. We shall see how today goes. I know we got a little delay, and we'll do a break around 10ish, because I know you guys always need a break. And we'll do a lunch break around 11:15, 11:30. Okay, so let's look at 6-3. Let's pull it up. Okay. We're still recording, great. Okay, so here you're asked to list all pairs of congruent angles for the figures. Then write the ratios according to supplying sides and a statement of proportionality. Okay, so I'm going to do the odds, then have you guys try the evens after I finish, just get some practice on your own. Pretty short, shouldn't take too long. So this symbol here is a symbol for similarity. So you would say triangle ABC is similar to DF. They're not exactly the same. They're not congruent. They are similar. So what it means is that angle A equals angle D. Angle B equals angle E. Let me do the angle symbols, it's probably better. Just be more proper. So angle A equals angle D. Angle B equals angle E. And angle C equals angle F. So that's gonna be all pairs of congruent angles. Then AB over DE equals BC over EF equals AC over DF. So I'm not gonna, it's kind of weird. I don't know if I should do the markings, but okay, I'm totally making that up. I don't know if that's really a thing, but the little squiggly sign means that those two sides are proportional. And then this right here, those are proportional. those are proportional. That's it. So for example, if this were 2, 3, 4, that looks more to scale. And if this were 4, what do you think the other two sides are going to be? 6 and 8. It's that simple. Yep. Because think about it. You got 2 to 4, 3 to 6, 4 to 8. Right? So that's all that's going on with that. So when you're asked to do list all pairs, congruent angles, that's that right here. When you're asked to do write the ratios of the corresponding sides and say proportionality, that's this right here. And remember, proportional means ratios of equal value. And what is a ratio? Just a fraction, right? Just a fraction. So AB when you need that fraction, it's the same value as B squared. That's the same value as A squared. So that's all. This is kind of a big idea for us for geometry, similar triangles. Questions? No. I'm so glad I had the projector working because I wouldn't know how to teach this without it. It's kind of sad. I'm so reliant on technology. Okay, cool. Let's keep the train moving. Okay, determine whether the polygons are similar. If they are, write a similarity statement. Okay. So there are actually 3 ways. To prove polygons. Actually, I lied. For polygons, in general, there's 2 ways. I was thinking of just triangles specifically. But for polygons specifically, I mean, polygons generally, 2 ways to prove polygons are similar. All corresponding angles are congruent. All corresponding sides are proportional. Those are your 2 ways. For a triangle, you could also do side angle side. I'll cross that bridge later with you guys. So let's look at number 5. Take a look at the sides here. What do we got? We got 3, 6, 4, 8, 5, 10. What's the ratio going on here between 3 and 6? What's the ratio here? 2. Perfect. Likewise here, and likewise there. Or you say 1 and 2. You go from left to right. So yeah, I'd say yes. And then you say triangle ABC is similar to triangle FDE. So you have to go in the right order with the angles, because A corresponds to that, B corresponds to D, C corresponds to D. I think we wrote this to make sure the second one is not out of order, because you don't want them out of order, but they don't correspond. We don't care about the alphabetical order bit. We care about angles corresponding to each other, right? So angles A and F are both right angles, right? So anyway, hopefully we're all good there. 7. Okay. Okay, I kind of gave you guys some bad advice. Okay, what I said here was for triangles, you only need one or the other. For triangles, you only need 1 or 2. However, for polygons in general, you actually need both. And I realized the error in my ways because when I looked at number 7, I was like, what if I had a square and a rectangle? Those are not similar, right? I'm trying to see if I see anything that's square in here. I can't really see anything just yet, but I mean, I guess it could look like those laminated things on the multiboard there. You know, those are all rectangles, but I don't think those sides are proportional. So, so you need both for polygons in general. So for number 7, it's going to be no. Yes, all the angles are the same, but if you think about it, if I compare this with this, because I'm going to have to rotate that bigger rectangle like this. So I have 3 to 6 equals 6 to 8. Those are not the same. That's 1/2 and 3/4. Oh, you guys can't see that. So let me get a highlighter out here. So I'm comparing, let me erase this here. I'm comparing this with this and this with this. Yeah, those are not proportional. K9, you're told they are proportional or they are similar. You have to solve for x. So in this case, you got to set 2 ratios equal to each other. I'm going to set 7. So this 4 corresponds with what? 6. This x corresponds with what? Boom, got it. 4 over 6 equals x over 12. Personally, I would probably reduce that fraction before you cross multiply, just to make the math a little cleaner for yourself. You don't have to. You still get the right answer, but just easier. So in 24 equals 3x, x equals 8. Very nice. X equals 8. That makes sense, right? 8 over 12 is 2/3. So you'll do something similar, no pun intended, for number 10. All right. Questions on 9. And that's a good test problem, something like a midterm problem, something like that. Okay. Lastly, 11, I'm going to have you guys try to evens. And then we'll check in about 5 problems. Should take you normally 8 minutes or so, 6, 8 minutes. Let's see here. Use a similarity statement, blah, 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 to find the scale factor. The scale factor is just going to be the numerical ratio, meaning that LM and PQ line up. Oh, sorry. Our corresponding sides. So 9 over 12 is my scale factor, or 3/4. It's kind of like, has anyone ever built like, I don't know if anyone does this anymore. I haven't built like model airplanes or model cars or model, okay, well, if you build Lego, you guys built Legos, right? Okay, good. At least you're not deprived children. Good. You guys built Legos. Assuming that, let's say you're building like, I don't know, maybe we'll do Star Wars because my son loves Star Wars, even though he hasn't watched his movies yet. But like, say he's building the Millennium Falcon, right? And and I mean, I know it's not a real Millennium Falcon in real life, but maybe there's a Disney World, who knows? But if you're trying to build to scale, right? So like, for example, like maybe the one part where like the little gate opens to go into the ship, right? Maybe on the Lego set, that's like 3 inches. In real life, maybe it's like 6 feet. So you want to make sure all those sides are proportional. So that's a scale factor, right? Because then you want to make sure all the other parts follow that same scale. So that's what a scale factor is. So it means I'm going to multiply 3/4 Or you could do the call like x and y if you so desire. So 15 over x equals 3/4. Also, 21 over y equals 3/4. And you solve each one. If I solve each one correctly, just trust me, x is 20. And y is 28. If you do that correctly. So that means this is going to be 20 here and 28. What does all that add up to? 60. That's our perimeter. Our perimeter is 60. Yeah. So we'll do things just like that in number 12. And in order for number 12 to help you out here, ST is what we're given for the left diagram. It's got to correspond to XY, which is 35. So that's how you're going to find your scale factor there. Okay, questions? Yeah, Sadie, go ahead.
Because it's 21 over 35.
Yes. You want to reduce that. Exactly. So every pair of sides has to equal 3/5. Every pair of corresponding sides. Yes, 100% correct. And then you can kind of label these like X, Y, and Z or whatever, or A, B, C. I don't care how you want to label it. Yeah, go ahead. Which number, sorry? The last problem? Let me go back. Here we go. And let me readjust. There we go. Any questions? Okay, you're good, Nina? Great. Okay, so let me give you guys 8 minutes to work on it. We'll talk about it. Afterwards, we'll do a little break. We'll do maybe a 15-minute break. And then we'll come back and do some more practice. So, well, good. Oh, the evens. Yeah, just evens on this worksheet. Yeah, 2, 6, 8, 10, 12. Let me pause recording. Okay. So for number 2, you're asked to list all pairs of congruent angles. So angle C equals angle M. Angle D equals angle J. Angle E equals angle K. Angle F equals angle L. That's all. And then the sides, you're going to say CD over MJ equals DE over JK. And all you know what I'm doing, I start with these two, right? Then I do these two. Then I do these two. And lastly, CF and ML. If you said LM, doesn't really, I'm not going to care about that, but CF and ML. Okay. So that's how you would write the proportionality. So questions, Sean, you have questions? Hey, my case is terrible. Yeah, I failed for drawing K's in kindergarten. Never quite figured out how to do it. We're 4 years old. I'm not going to figure out any time. Here, I have to be very mindful. So Kale, there we go. Okay. Next up, number 6. The answer in this case would be yes. That's because you have 4 to 6. And you got yourself 6 to 9. Those are the same. Yeah, and everything else lines up. The angles are the same. So I would say yes. And I'd say you know, if you could go JIHG is similar to NMLK. Yep, NMLK. Question about 6. Nope. Next up, I'm going to say no. Or maybe, I don't know. Hold on. Let me scroll down. Actually, that's a yes. Actually, they're congruent. If they're congruent, they're also similar. If you're congruent, oh, can't read that. You're also similar and congruent. And what I would do is I have to rotate. I got to take this triangle and rotate it. So what's going to happen, that's A, that's B, that's C, 3 markings, 1 marking, 2 markings. So the other triangles, if I rotate it, 3 markings, 1 marking, 2 markings. And that's going to be D up top, E down here, and F. Yep. So you would say then, I mean, of course it's congruent, but triangle ABC is similar to triangle FDE. Okay. Questions? No. Okay. These here, you have to solve for X. So DE is same as MJ. Hold on a sec. I don't see that. I don't know if we could assume that's 12, but CE. Okay, this is kind of not drawn. I think the assumption is that that's 12 and 8. I think you had to be told that. It's not terribly precise. So then the 8 corresponds with the 12. And this 12 corresponds with this X. So what I'm going to write is this. 12 over X equals 8 over 12. You can reduce if you like to 2/3. 36 equals 2X. X is 18. Yeah, that wasn't really done properly because DE is supposed to correspond with MJ, and you're not given MJ, but I guess you have to assume that's 12 and it's right angles. So not the most well-designed problem. But hopefully you guys got 18. I'm guessing you probably assumed these are both rectangles. And lastly, for 21. So ST corresponds to XY. So your scale factor is 21 out of 35, which reduces to 3/5. Then what you have to do afterwards is you're gonna have to do if you call this A, TU lines up with YZ. So A over 25 equals 3/5. Then I'll call this B, UV lines up with ZW, which is 20 here. Come on. And lastly, C, WX the SV WX. So C over 20 also equals 3/5. You solve each one. A is 25. Wait, no, 15. What am I thinking? 15. 5B equals 60. B is 12. 5C equals 60. C is also 12. So those are the sides. Okay, questions? We're good? You guys ready for your question? Good.
No.
No questions. Good. Okay. So let's take a break. Let's come back at 10:20. And then after we come back from the break, probably we'll try to sneak in 2 topics. And then we'll do a lunch break around 11:30. We'll come back at 12. I think we'll be done by 12:30. So if you guys want to kind of text your parents or whoever picks you up, we'll be done by 12:30 today. So. All right, but yeah, if you guys come back at 10:20, that'd be great. Perfect. Okay, cool. Well, let's get the train moving again. Let's start now on 6.4. So just 2 more topics. And again, we're not going to do 6.6, so I'm crossing that one off. It's in Schoology, you can just ignore it. So what's this about? 6.4. Okay, it's more of the same stuff. I don't think it's okay. I think we do get into the 3 ways of proving that triangles are similar. Okay. And again, I'll do the odds. Actually, you know what? I'll do the evens just to make things go a little faster. Let me share my screen. 1 sec here. Yeah, I'll do the evens. Then have you guys do the odds so you can check your answers. Okay. So looking at this diagram here, it's pretty clear that these are similar because that angle corresponds to G. So I'm definitely gonna put triangle G. Okay, I am doing the evens. Sorry, I am doing the odds right now. It's okay. We'll just reduce your work a little bit. And we do see that O, it's a different color. We do see that O matches up with H. And then naturally, N would line up with, I think it's an I. Can't tell. I think it's an I. Okay. So MON similar to triangle GHI. And notice that you only need 2 pairs of corresponding angles to be congruent for similar triangles. Okay, you only need 2 pairs because naturally, what if these are both like 40 degrees, these are both 60 degrees, right? You're gonna have 80 degrees left on these 2, right? So then you only need 2 pairs. So yeah, I'll do the odds, and then I'll show the even answers afterwards. So for number 3, you want to solve for this question mark. I'll call it X, and I'll probably reduce this to what? 4/3. Is that right? Yeah. So 40 equals 3x. So you get 40/3. Okay. Actually, I don't know why I called it X. That's a little confusing. Let's call it A. That was a little confusing because there is an X in the problem. So that ratio, if you were to solve that proportion, you get 40/3. You didn't have to reduce to 16/12, you still would have got 40/3 anyway. which is like 30, no, 13 point something. I think 13.3 repeating. Then let me erase this stuff because it's getting a little busy. How would I make an equation for number 5? So what would you compare? How did you make an equation with that stuff? So x corresponds to what? 16 corresponds to what? Perfect. Thanks, Sean. So actually, we kind of just did that. 16 over 12 equals x. Okay, we just did that problem. Okay, there we go. That's kind of lame. I don't know why they repeated their efforts, but you get the same thing, 40/3. That's hard to read. Yeah, so 3 and 5 are identical questions. Nina, go ahead. Do you go ahead, Nina? Same thing. Same thing. Yeah. They just rose a mixed number. Or 13.3 repeating. That's a 3. My goodness. Yeah, 13.3 repeating. I really struggled doing 3s on the laptop here. Okay, so you guys will try the evens on your own. Let's keep moving. Determine whether these are similar, not similar, cannot be determined. Okay, so there's something called, so now, this is what I meant to do earlier today. 3 ways to prove triangles are similar. Okay, 3 ways. 3 ways will be this. Angle, angle. So AA stands for angle, angle. There's also side, side, side. And then PROP stands for proportionality. And there's SAS. Hopefully you guys can see that. Yep. That stands for proportionality. So what happens is that if you have 2 pairs of angles that are identical, you could say that the triangles are similar, and then you have to kind of make the statement correctly, you know, putting the corners in the right place. If you have all 3 sides are proportional, you could say side, side, side proportionality. If you have side angles, like if an angle between 2 sides and the sides are proportional, you could also use that as a reason. So in this case, if I have 92 and 57, that's 149, I think. So that's 31 degrees. And that's 133, so that's 47 degrees. So the answer is no, not similar. Here for number 11, 76/7, that makes that 43. But here's the deal. I don't know. I got no clue what's going on with these 2 angles here. I have no idea. I know that 137, I don't know if they're 76. I have no idea. So this one, I would say, cannot be determined. We're not going to say no for sure, because it could be, but we're not sure. Okay. It seems like all these just deal with angle situations. There's no side, side, side proportionality, side angle, side proportionality just yet. But that's another reason. Question about 9 or 11? Nope. Okay. Let's do more of the odds. Okay, now we're going to talk about side angle side and side proportionality. So let's look at 13, 15, 17. Now have you guys try the evens. Okay, if that is 38, you want to do 180 minus 38, which is 142, right? It's 142. Oh, that's not a good 38. Now, what happens if you divide 142 by 2? What do you get? 71? Okay, good. So you get 71 here and here. And that's also 71 because those sides are the same. So that's 38 right there. Okay. Yeah, these are similar. So that's good enough. And then you could just say NMO is similar. If you go NMO, you can say QRP. Also could have said PRQ, that would have worked also. Because you have two isosceles triangles. You can also prove by side angle side because you would think that the sides are proportional as well. And Neil, go ahead.
On the statement on the bottom, what's the letter?
Yeah, yes. Yes, it's a vertex angle, the top angle. Let me write that better. NMO. There we go. Okay. So yeah, that's all yes. What do you guys think about 15?
What kind of triangles are these? All three sides of each triangle are identical.
Sean? Equilateral. So what's the measure of each angle?
60.
Great. All the corresponding angles match up. Both equal. Goodness. Let's do that again. Both equilateral triangles. So all angles. The answer is yes. And you can say triangle DFG. It doesn't really matter because all the angles are the same, but you're going to say similar to triangle, say RST. It doesn't really matter how the order. If all the angles are different, if it's scaling or if it's isosceles, then you kind of be a little bit mindful of the order. Okay. So that's a yes situation as well. So yes for 13. So you have to kind of dissect the triangle a little bit and really kind of see, okay, what are the angles? How are the sides comparing? What am I dealing with? You know, do I have all corresponding angles equal to each other, right? Okay, last one. Ooh, that's a good one. This is a really good one. I like this. This is building upon, this is a great midterm question because it builds upon what we did in the previous couple weeks. What's true about these two angles here? They're vertical. Are vertical angles always congruent? Yes, yes, they are. Also, these are parallel. So when you have parallel lines, okay, those are going to be the same. Also, those are going to be the same. So that is the same as that. And that is the same as that. Alternate angles are equal. Okay. So yeah, this is yes. Yes again. And you're going to say triangle X, you know, I color code to make it easier for ourselves. So YWX, I guess you could say that is similar to triangle YZV. So there you go. So that's another similarity. So it seems like all these are dealing with angles. We haven't had any side angle, side situations. Okay, questions. So again, just look for that. When you have corresponding angles that are equal, and you got to use sometimes your old stuff that you've learned, parallel lines, vertical angles, right? And you make that connection. And you can see, yeah, they're all similar. They give you the reasons right there. So, okay, so you guys are going to do the evens. So you have 2, 4, 6 that deal with this situation. You got 10 and 12, staying whether those are similar or not. So just look at the angles really. And then you got 14, 16, 18. I'll go over the answers with you guys. So I'll give you guys, that's 9 problems. Might take a little while. Talk to each other, help you call me over. Definitely by 10:50, I want to go in about 10 minutes, I'll say. Because by 10:50, I kind of want to go over the next topic, and then that will finish. And then it'll take us into the lunch break around that time. So yeah, do the evens. I'll work these out also. And I'll share my answers with you guys in just a little bit. All right, so let's do the evens. Let's pause the recording. Okay, so let's talk about, actually, hold on. I gotta go over the answers, you guys. What am I doing? Yeah, let me show you the answers. I'm losing my mind. Here we go. There we go. Okay, here are the answers. So again, we're gonna call this I. So MN,
We're GI because MN matches up with GI. ON matches with HI. And MO matches with GH. Because there we go.
and then for number 4,
You actually have to line up the diagram. So 12 over 16, which is HI for ON, definitely is going to equal 8 over Y, which is GH over MO, as we stop here.
so you need to put 8 in the numerator, and then you're actually solving in number 6. Now I understand what's going on with number 3. I was right in putting an X there because it corresponded to that X. I didn't quite realize that initially. And I guess number 5 is asking to solve for number 3. Number 6 is asking to solve for number 4. And if you solve it, you should get 32 over 3 or 10.6 repeating, or 10 2/3. If you want to do a mixed number, totally up to you. I don't care how you express it. You know, just make sure you get the relationship correct. So question about 2, 4, 6. Again, those are relationships right there. MN over GI equals ON over HI equals M over GH. Where you see the question mark, number 4, you put an 8 there because they correspond. And number 6, Y is 10 2/3 or 32 thirds or 10.6 repeating. So hopefully we're okay with that. Okay, let's keep moving. For 10, 10 and 12 are both similar, by the way. Let me reduce. 10 and 12 are both similar. All you have to do is just find the missing angle. It's not that hard. You do 180 minus some of the other 2. And you find that, oh yeah, all these angles correspond to each other, right? 48, you have 248s, you have 255s, you have 277s between both triangles, A, B, C, and D, F. So they're totally similar. That can be determined. And then also, yeah, those are as well. If you have 90, then, and these other angles are equivalent or congruent, then that can be 45 each. And how do you know that these are going to be 45 each? Because these two sides are the same. Remember, we have an isosceles triangle. The 2 angles opposite are always going to be the same. So anyway, you have 45, 45 for both, and a 90-degree angle for both. So both these are similar, right? And then 14, you can't determine. I mean, to find out 60, angle would be 60. I have no clue what to think of angle here. I have no idea. I know they have 90, that's 90.
I got no idea how to chalk that up. It was a 45, 45, 40, 50, is it 70, 20, is it 80, 10? I have no idea. So you're not gonna say it's
Not similar. We just don't know. We can't determine. Since we have no idea about angle M or angle K. And by the way, that's supposed to be angle. That's an angle symbol. My bad. It looks like an L. For 16 and 18, find missing angles again. If you have 62 for angle ABE, then that's 28 for ABE. That's 20, that's 62. So those are similar. Corresponding angles are congruent. Those are totally similar. And likewise for 18. 18 is a tricky one, but here's the deal. If you redraw each triangle, RST and QSU, or SRT, SQ, however you want to call it, they both share angle S. Yeah, Sadie, go ahead.
For 16, because there isn't a right triangle, how can,
Well, if that's a right angle, that's also a right angle.
oh,
Because they're on the same line.
okay, cool.
They're a linear pair.
Okay.
That 180. Yeah, my handwriting sucks, I apologize. So similar, since angle S is shared between the small and the big, and that's parallel, right? Remember that symbol means parallel. You got to be able to read math correctly. That means parallel. That means that these are corresponding angles. Those are corresponding angles. Okay. Angle Q equals angle R. Angle U equals angle T. Now you got all corresponding angles equal. You totally have similar triangles. Similar triangles will exist here. So yeah, actually all 6 of them were similar. Yeah, then you could. Oh yeah, I'll let you keep talking. And again, this is being recorded, so if you want to watch it again and make sure you understand, like, oh yeah, you know, what did Mr. E say about that? Parallel lines, right? You got parallel lines here. So there's a totally going to be, it means that these corresponding angles are going to be the same with each other. So, because that's what we have for parallel lines, right? Right, those are the same. Okay, let's keep moving. Okay, now finally, let's do 6, 5. Let me pull this up here. Okay. So just so I pace myself appropriately. Okay, not too bad. So I'll be doing 6 problems with you guys. Then I'll have you guys try 6 problems. Then we'll do lunch break. So I believe now we are going to start talking about side, side, side. Proportionality. So what you want to do is look at AB over DE. What's that going to be? What does that reduce to? 12 or 8? What does it reduce to? Close. 3 over 2, yeah, 3 over 2, thanks. Okay, let's look at AC and DF. That's 9 over 6. What does that reduce to? 3 over 2 again, bingo. And then lastly, BC over EF. $15 over 10. Winner, winner, chicken dinner. Let's say that phrase. So 3 halves. Sorry, I was being a little silly. So you have 3 halves. 3 halves, 3 halves, 3 halves. We got a winner. So that's a little annoying. So that's called side, side, side proportionality. So the answer is yes. Actually, I don't even know why I circled. Well, it's good I circled 3 halves, but what you have to say is yes, they are similar because of that reason. And you guys show, right, that like, hey, you know, AB and DE, AB over D is that, and so forth. So, okay,
questions about number one? All right, let's move on. Determine which two of the three triangles are similar. Find a scale factor. Ooh, this is interesting. Okay. Well, I mean, obviously, I don't know that angle, nor do I know that angle, right? And likewise here. I don't know that angle, nor do I know that angle. So I don't think I could really look at angles here. But we could look at sides. I have a feeling it's going to be these two. So that's just by kind of inspection.
Because if you think about it, what's the ratio between 4 and 2? 2. How about 7 to 3.5? 2. How about 6 to 3? 2. You're not just seeing that over here. 5 to 2 or 7 to 3. That's here. 5 to 4, 7 to 6. Okay.
So the left triangle is just way off base. And then the scale factor is just going to be 2 to 1. Or you could write as 2 over 1. That's fine too. So that's number 3. So you got to determine which pair of triangles are similar for number 4. So we'll do that in a little bit. Questions about that one? No? Okay, we're at the home stretch here. We guys do some practice. 5. Let's look at 5. All right. Now this is gonna be side angle side proportionality. Because you have two sides and an angle in between. So we need is that you need two pairs of sides that are proportional and included angle that's congruent. Okay. I think we're gonna be okay. Let's look at RS. Oh goodness. Let's look at RS over XY. So you have 4 over 6, which is 2/3. Let's look at ST over YZ. You have 6 over 9, which is also 2/3. And angle S equals angle Y because both are right angles. Okay. Yep. So the answer is yes. Due to that reason. So I knew that we were gonna have to talk about this. So we did side, side, side for the previous two problems. Here we're doing side, angle, side. And so, yeah, if you're given two sides that are proportional and the angle in between them are equal, you could say these are going to be similar. I mean, if you want to do Pythagorean theorem, go ahead, do Pythagorean theorem to solve for these two sides here. If you want to, go ahead. And you'll find it to be side, side, side proportional. That's just a lot of extra work. I wouldn't do that necessarily, but you could. If you really want to get fancy, you could do trigonometry, which we haven't done. We won't do that until later this month, and find what angles R and T are. But you guys are not equipped to do that yet. So for now, we just do side, angle, side. So you'll do something similar for number 6. And the scale factor was 2/3. Scale factor is 2/3. Okay, questions about that one? All right, let's look at Okay, so I was gonna do odds. So I guess I'll do 11. That's weird. Okay, numbering system's off here. So I'll do the right column here. Are they similar? State your reason. Okay. And then state which ones are, how would you state the similarity? Okay. 11, I'd say yes. And you can say triangle MTC and SRA, but it doesn't really matter what order you do. These are some due to both being equal out triangles. Yep. So both are equal out triangles. Okay. Equal to 11. 13. That's weird. It's really, really weird. I don't know. I mean, you could redraw them like this. That's N, M, and Q. And that's P, N, and O. Yeah, I don't know. I mean, I have right angles, but and you can say, like, for example, you can say this is 5 and 5. I'm just totally making that up, by the way. I don't know if that's, but yeah, I just don't know. Not enough info. Yeah, go. Yeah. So we're not sure. Yeah, that just doesn't tell us anything. So I have no idea for 13. Okay. And last up, number 15. It looks like, I don't know why there's an exclamation point, should be a degree symbol, but whatever. Yeah, I'd say yes. If these are each 30, and each of these are 75, 75. And likewise here, because you have isosceles triangles again. So yeah, I'd say due to angle similarity. I remember you have two. So base angles are congruent, and isosceles, let me spell that, let me abbreviate that better. Yeah. Okay. Okay, so now we have you guys do. Why don't you guys try evens? So 6 evens. Give you guys maybe about 12 minutes or so. So about 11:20ish, we'll talk about it. We'll definitely do a lunch break at 11:30. So go and try those now.
Ask questions.
You guys are stuck? No. Yeah, go ahead. Pause. Okay, so let's go through the events here. And if you guys lunch break. This one I would say, yeah, you have 18 over 24 equals 20 over 28, which equals 33 over 34. All of them are 33 over 44. All of them are 3/4. Every single one. And let's do the side proportionality, just like number one. In here, I would say, let me think here. 5, 4, no, 4/5. Yeah, I would say this one with that one. I think so. Am I wrong? Yeah, I think I got it. Yeah. Triangle ABC is similar to triangle GHJ. Scale factor is going to be 24 out of 30. Divide those by 6, you get 4/5. Yeah, scale factor is totally 4/5. Wait, did I do it right? 5. Yeah. Yeah. Okay. So that's number 4. Then for number 6, verify. So 16 over 28. What does that reduce to? 4/7. And 12 over 21 is also 4/7. And include angles are the same. That's side angle side proportionality, just so you know. For 10, that's going to be 31 degrees. That's going to be 47 degrees. We have a problem. Those are not similar. So that's number 10, because those angles don't match up. Hopefully you guys can see. Hopefully that makes sense. Do you need me to rewrite that? No? Okay. And then what do we got? We got 2 more here. I'm gonna do lunch. Yeah, that's me, yes. Side angle side proportionality. And you can say triangle FDM. Is similar to triangle FDM AVQ. AVQ, I think. Yeah. And finally for 14. Yes, I would say yes again. Because that's gonna be 9, and that's gonna be 6. And that's gonna be yes due to side proportionality. Yeah, because you have 9 to 6. If you compare these two here. equals 4 to 6. No, 6 to 4. And you compare these two. So yellow. So got your suggestion? Got it, yeah. Okay, cool. Yeah, and so this, when you state it, you have to say triangle, you can say triangle ABC is similar. You could go either X, Z, Y, or X, Y, Z, it doesn't really matter. Yeah. Okay. So that covers all the new material. So we're going to do this after lunch break. So let's come back at 12 o'clock. So you guys a little more than 30 minutes. Let's come back around 12 o'clock. Let's do some of the homework problems together, kind of knock those out. So that kind of reduces your workload. We'll definitely be done by 12:30 today. But let's come back at 12 o'clock. So let's get a little lunch break and we'll be done a little early. Okay. So here's what we're gonna do for the next like maybe 20 minutes. So yeah, we'll be done early as I promised. So in School G, if you click on homework and then click on homework number 9, you'll see I assigned some textbook problems. I also took a scan on my phone just an hour ago and upload it. You guys have this in your packets too. It's actually going to be the last few pages of this packet, so you guys have it. And these are problems I'm suggesting that we do, or you do. You know, page 465, 467, these problems here, 474, 477, 44, 47. Very similar to what we talked about earlier today. So I'll kind of get you started a little bit. Maybe I'll do like a handful of problems, like maybe 2 or 3 problems from each set, and then kind of have you guys try some, and then for around 20 minutes from now, we'll just end class. I think that's a good thing. So, and also later today, I will upload the recording from today. So once class is out, I'll shut down Zoom. Yeah, so camera's still on, so I have to keep Zoom open. So I'll shut down Zoom, download the recording, I'll upload to YouTube, share the link on Schoology. I'll create some midterm review stuff later tonight or this afternoon, and whenever I get it done, I'll put it in Schoology. Tomorrow we are going to be remote. Sean, go ahead. I did. Yeah. So whatever you see circled in the PDF. Yeah. So maybe it's easier to work in the PDF perhaps because it's all circled, or maybe if you have the packet but it's all there. Yeah. So I'll upload some review materials for the midterm tomorrow. We are remote tomorrow, and then we're back to in person on Thursday. Again, the first hour we'll just do some review, take a little break, start the test. And should be done around 11:30 or so, just like we did last time. So should be pretty straightforward. Should be a paper copy. I will also upload an opportunity for test corrections. We're going to do test corrections for test number 2. Now you have it back, so you could do that. And you know, I offer for all tests just to be equitable. Probably will do it for the midterm too, but the final exam, unfortunately, just can't because that's just class is over by then. And as long as it doesn't, I mean, if it's going to make a big difference in the grade you need, talk to me. I'll work with you on a case-by-case basis. But I offer it for all the other exams, the test corrections. So yeah, so let's take a look at it. So I'll stop yapping and so let's start getting to work here. So I said 357, right? 3579. So here it is. So you have to identify pairs of congruent angles and corresponding sides. So I think it's pretty obvious what the corresponding angles are going to be. It's pretty clear A corresponds to H here. It's pretty clear that C corresponds to K there. And then of course you can gather, you can say D and L or D and J, it doesn't really matter. Or B and J, B and L, doesn't matter. And then the corresponding sides, you know, AD and HL, AB and HJ, or you can mix it up, DC and LK, or DC and JK, or BC and LK, BC and JK. So, and another thing too, if you want to check the answers, if you go over here Should have put it somewhere else, but the whole textbook is right here as well. So you can, if you just go all the way to the end, you could totally see all the odd answers. So I only said odds. Let's go back to homework again. You guys might want to get a head start with that. And then like some of the problems, like you see 7 and 9, very similar to what we did in the worksheets. Identify pairs of congruent angles corresponding sides. Determine whether the polygons are similar for number 9. 13, 15, 17. I haven't done enough of these with you guys because this is kind of a common thing you do in geometry. These are like, is it always true? Is it never true? Is it sometimes true? Actually, let's do these right now. For number 13, are right triangles always going to be similar? No, right? Because that could be like 45, 45. That could be like 30, 60. There's no guarantee. No guarantee. So, but it could be. It could. I can make a bigger triangle that's 30 and 60. So that's going to be sometimes. I'll put S for sometimes. A parallelogram. It's like this. A trapezoid is when you have just one pair of parallel sides. But parallelogram, you have 2 pairs of parallel sides. But trapezoid, just have 1 pair. Are those ever going to be similar? Just look at it. Do they have the same shape? Nope. The angles look different. This is never. I'll put N for never. If 2 polygons are similar, could we say they're congruent? Is it a sometimes? Is it always true? Or is it never true? Let's say I have a square. And I have another square, but it's much bigger. They're similar, but are they the same? Are they identical? But it could be identical. I mean, identical shapes are also similar, so it could be. So that's a sometimes, just so you know. And then let's do a little algebra for 19. So they're similar, okay. How would you set up 19?
I do x3 equals 3.
Oh, sorry, repeat it one more time.
X3, x plus 3 equals, x plus 3 equals 4.
Right, exactly, yes. You could set up a ratio, but it's not necessary. I think I like the way you're thinking this problem through. Oh wait, isn't that interesting? Hold on, wait, hold on. Stop the presses here. A, B, C, D, A, B, E, F. Ooh, isn't that interesting? I think this problem's a bit flawed because you could do that. You get x equals 1, but then that won't work for the other one, right?
Yeah.
Yeah, so that's kind of weird, actually. Actually, they don't have. Actually, no, they're not identical. Now I know why we can't do that. You could do that if they were identical. So here's what you want to do. You want to do 4 over 3. Sorry, the problem's not flawed. It's just that we didn't read it correctly. It's they're not congruent. So you have to do that and then cross multiply. I'll let you guys work that out. But that's how you would go about 19. That's a setup there. And then the next problems, oh yeah, there's a couple multiple choice. There's one multiple choice and one short response. So you have to be, so you're looking for proportionality. If you want to make these similar, so you're going to say 4.8 over 8.4 equals 14.4 over y. Here you may want to draw like 1.5, 2.5, and 3.5. Say good. Oh, 19, yes. Let's go back 19. Yeah, so right, so you're gonna do 4 over 3 equals x plus 0 over 2x minus 4. And you have to cross multiply. Yeah.
No, and then after that,
Oh, yeah, exactly. Yeah, right. Right, and then you solve for x, exactly. You combine like terms. Can't redo, but yeah, anyway, explain why they cannot be corresponding to the size of similar triangle. So 1.5 and 6 is 1 to 4. 2.5 10 is 1 to 4, but 3.5 12 is not. So there you go, I already answered that for you. Next set, explain why these are similar and write a similar statement. So that's going to be 47, I think. And that's going to be 81. So there you go. Here you're doing side, side, side proportionality. You compare 6 to 12, 8 to 16, 10 to 20, not that hard. Here, you have 9 to 15. So if you try to find AB, because these are similar, because they have these that are same and they share angle A. So again, whenever you have two pairs of angles that are the same, you're told that E and EC are the same, and both triangles share, when I say both triangles are small and the big, share angle A. So 9 over 15 equals 6. I'm gonna call this whole thing X. And you solve for X for that one. Yeah, so again, that's similar triangles. Let me just have you guys work. So we're going to guys work for the next 10 minutes. Check in, ask questions, and then we'll end class after that. Again, here are the problems, so we don't have to open up Schoology. You guys can read that. I mean, here we go. Any questions so far? No? Just know the last prompt set might seem a little tricky, but try to use your intuition. Those are page 484 to 487, I believe. Kind of share some of the answers for the beginning problems. For number 5, do you guys say yes for number 5? Yeah, good. I agree. It's definitely by side proportionality or angle. 7, that should be hopefully pretty straightforward. 9, I would say yes for 9. And the scale factor, I think, is 7 to 8. Where is it? 13 through 17. 19, if we work that one out, again, 4 over 3 equals x plus 3. So 8x minus 16 equals 3x plus 9. 5x equals 25. X is 5, which makes sense because that would be 8 and 6. So follow 2-to-1 ratio. Um, 29's no, because proportional is 1.5 over 6 or 2.5 over 10. (27) if you work that one out, that should be 4.8 over 8.4 equals 14.4 over y. Yeah, use a calculator for that one. Let's see, 14.4. Let's calculator. 4.8, 14.4 times 8.4 divided by 4.8 Yeah, you should get 25.2. So you got one set done. So keep working on the rest. Shouldn't take too long. We'll go over on Zoom tomorrow, and then I'll have midterm materials prepared for you guys that you probably print at home. Probably reference sheet. And again, it's going to be open note again. You can use notes on midterms, totally fine. Yeah, it's well anyway. It's almost 12:25 to let you guys go. So you guys are free to go. Enjoy the rest of the day, and I'll see you on Zoom tomorrow morning at 9 o'clock.